Okay guys, so today I'm going to try and show you how to download some data from USGS Earth Explorer. Specifically, I'm going to download a Landsat8 image. Then I'm going to bring the image in, the files into ArcGIS Pro. I'm going to basically merge all the bands so I have a single raster with all the bands loaded in it. Like most remote sensing products that you'll use in our classes are already set up that way. When you download the data, a lot of times they come individually and you've got to figure out how to package it and put it together. So I'm going to show you how to do that. So we're going to USGS Earth Explorer first, and then the rest of what we're going to do today is on ArcGIS Pro. Some of you have used it, some of you are new to it. All the functionality that I'm going to show you today is also available in ArcMap. But Esri is going to ArcGIS Pro, and it's becoming more and more user-friendly and really a very capable platform. So I'm making the migration to ArcGIS Pro. So first, my study site is going to be Valencia. I went there this past summer, and I love it. And I thought an interesting part of the world we can look at. So we're going to download a Landsat8 image. We're going to bring all those files together in Arc Pro. We're going to do a principal component analysis with those bands. We're also going to do some pan sharpening as well to kind of show you a lot of the functionality we've been exploring with inside our remote sensing class. So the first thing they want you to do inside this website, we can zoom in and out of the map itself, but they're going to specify a search criteria, and you can just kind of specify using four corners by touching on the screen the area you want, and just be aware that any overlapping area that the coverage of the satellite image might hit will get selected. So if you don't want a lot of this water, we can move that in. And then the next area we want to do is click on data sets. There's a lot of really great data here. There's some commercial satellites here that you've heard about before: Iconos, GeoEye, OrbView. I actually downloaded an OrbView 3 image not too long ago. It's just a straight panchromatic, pretty decent spatial resolution. I'll show you that. QuickBird WorldView is there. I'm not going to mess with that initially. I'm going to go down to Landsat, and we're going to do Landsat Collection 1. Kind of explore this stuff, and let's just say Landsat8. We can do some additional criteria if we want, and say, no more than 30% cloud cover, and then we can hit results, and then we just wait, and really quickly the results pop up. There's a bunch of functionalities here. We can see the footprint of the image itself, so this certainly works. It covers the bounding box there. That could work. This one covers it as well, kind of the southern portion. You can just kind of turn these on. They give you the different colors associated with it, and you can kind of figure out which one you like the best. It also shows you the acquisition dates here. You can see there's two of them from March of 2014, and you can see in the bottom of my screen this is the 18th. And I was looking at this last night. In fact, I downloaded this file last night to save time. So it's only 3 or 4 days old, which is pretty amazing. And how rapidly we can get this data. So I'm going to download this data. Some things we can do: you can click on the thumbnail, we can preview the file if you want. Of course, when I'm recording it, it won't let me do that, but I've seen it and I know that it works. We'll hit the download options here, and it'll give us the option to download the data. And there's a series, so here's our thumbnails. Everything's popping up due to the delay. But you can see what the data looks like, and then we can see the different download options. The file size is a pretty good indicator of what you're going to get when you download this data. we're going to use the level 1 GeoTIFF data product that's got all the different bands associated with it, and we'll download that, and it comes in a zip folder, so you'll need WinZip to offload all the data. So you click that, you download the data. It took me 15 minutes to get all the data downloaded on a BIOS connection at home the other day. And then you're off and running with your data. So I'm going to close down that. Here's my folder with all the bands that downloaded when I collected the data, and there's some README files and some other things in here as well. These two I created just a few minutes ago, so that's not what got downloaded. Everything else got downloaded. You can kind of look at some metadata. We can open the individual bands, so you can see it's just a grayscale, 0 to 255-bit grayscale image at the different bands. When we're thinking about image enhancement, you can tell there's not a lot of high reflectivity in this particular band. So you may be doing some stretches with your data to make the data look good. Okay, so the next thing that we need to do is bring up ArcGIS Pro and load the data, and I've done that. This is Landsat8 data. Right here, I've got the bands 5, 4, 3. So one of the things you want to know when you're dealing with your data is what the different bands actually represent and are. Landsat8 has band 1 is not the traditional blue band, it's something else. So you can zoom in and you can look online and see what each of the bands really represent, but a 5, 4, 3 band representation is color infrared, and we can zoom in here. I like to look kind of in and around the port area, and you can see a nice beach, things of that nature. We can change this to kind of a true color representation, and you can kind of now see some vegetation in green, the urban area this way, and the water, near coast water as well in this port. I was really impressed with this data. Now, this is not how the image originally comes in. I created this Landsat image through all the different bands. So you can see all 11 bands are available here, but it doesn't just come that way. You've got to make this file. To make the file, you can go into Tools, go into our geoprocessing here. We can search for tools. The tools we want is composite bands. Here she is. And when we do that, you enter all the rasters from that folder. So we do each individual band here from my desktop that I had. And so band 1, 2, 3, 4, 5, 6, you can see at the end of the file of each of these TIFFs, I loaded all 11, and then my output raster was called Landsat Valencia 8, and it kicked out this product. So, it looked like when I first brought up ArcGIS Pro that, boom, I have this beautiful Landsat file raster that's got all 11 bands in it, and we don't. It actually has, you have to go through the composite bands tool. Once you do that, you can manipulate each band in a different color gun and see your color IR and your true sort of color image. Okay, so that's how you download the data, Landsat data, pretty quickly. Only a couple days old, really. You can look at it in true color. You can look at it in color IR. You can see just the sheer area of space that this covers, and it's pretty amazing. And when you look at the background imagery inside ArcGIS, you can tell it looks a lot like Landsat imagery, doesn't it? Okay. The next thing I want to show you how to do is principal component analysis. Now, we're talking about that in upcoming lessons. We also talked about a pan sharpening technique using principal component merge. So using the first principal component band as kind of our big time reflectance band over multiple channels in this particular case. But whatever the reflectance is, kind of in a panchromatic high resolution image, we can use. Now, we're not doing that in this particular case. we're just doing the principal component analysis, creating those bands in principal component analysis. And principal component analysis is interesting. It's all about an eigen problem, and there's some readings you need to do to understand what's going on. We'll talk about principal component analysis in class, but I want to show you that the tools here in ArcGIS Pro as well. And so if we go into geoprocessing, we got to do a search for tools, and we can simply say principal was there, principal components, and we specify our information. So we have to enter our bands again. So the same thing I did last time is I would enter all the individual bands in this again, and then output the raster principal components, and I'll call it principal component 1. So I've done that already. It takes again another 10-15 minutes to run this process, but I've run it. Now the interesting thing, before I show you what a principal component analysis looks like, the bands aren't anything like, they won't make sense to you initially when it opens up. It's really looking at the variance of the reflectivity of each individual band, where all the variance is and big changes are. So it's good at, when you're talking about changes inside the image, it's good at identifying what's different from other things. So for land use classifications and things like that, it's pretty useful. So I'm going to turn it on. This is not the right one. Here's our principal component analysis. And you can see very weird and different sets of colors. And there's a bunch of different bands available. So if I go into my principal component guy, each of the bands, you can see there's 11 bands. So there's there's a principal component band for every band available when you run a PCA. Band 1 is the one that we say has the most variation or most variance inside of it, and it's really, when we talked about our principal component merge, we talked about we're looking at changes in reflectance and most variability, and so it almost looks like a black and white image, as it should, and that's what we've got here. In this particular case, we're using the different bands to look at this, and the resolution of the bands aren't particularly better. They're not better. They're the same as Landsat. So we're not going to be able to use this particular PCA band 1 with panchromatic or for sharpening of a different image. But if we had a black and white better image of this area, we could replace it and do a reverse PCA to pan sharpen. And I actually have that. Here is a better high resolution image in this area. So if we wanted to, we could use that image to pan sharpen and do a reverse PCA. I don't see that as an available function inside ArcGIS Pro. I haven't looked in depth yet at it, but that's another, they are tools in other software programs that you've experimented in our class with already. But that's principal component 1 and how you get all the bands available. I do want to show you that using this particular image in our Landsat image, that we are able to put our Landsat back on. We are able to do a pan sharpening. So if I go back to tools, again, the search in ArcGIS Pro is great because all you got to do is search in what you want, and you can make this happen. Create pan sharpened raster data set. If I click on that, I can input my raster. At this point in time, I can enter my actual Landsat8 raster that I created through the composite bands functionality, and I specify what my different channels are. So if I say Landsat8, my red channel is actually channel 4, my green channel is actually channel 3, my blue channel is channel 2, and my infrared is channel 5. I specify my output, in this case is pan-sharpen 3 because I messed around. Then I've got to specify my panchromatic image. That's going to be my this guy here. And then this gives me the type that I want to do. Some of these you'd be familiar with, and you can always hit the information button to learn more. I'm going to show you the Brovie transformation technique. I did it. It worked pretty well. Again, it took probably 5 minutes to run this tool in this one particular window where I have this nice OrbView satellite image. And I'm going to show you the results of that now without actually running it because I did it a minute ago. And this is the pan-sharpened image. It looks interesting, right? Let me turn off the world imagery in the background. First of all, it's only in one little area. The colors look significantly different, but it's because I've got the bands set to basically try to look like a color infrared image. Notice a couple things. One is that if I turn off panchromatic, we've got a pretty interesting harbor here that when I look at just the Landsat that's 4 days old, there's more to it. You can see right here this guy exists, but all of this does not in the panchromatic. So there's some things that have changed, and so you'll see some color changes when we go into the panchromatic. The yellow stuff is kind of new developed items here, and that's kind of what ends up happening is you'll see some things, you can detect things that have changed. Additionally, we can go back and we can change our Landsat to be kind of a color IR image. This. And then now we're kind of we're looking at the same bands. I like to kind of zoom in right here because we can see in our pan-sharpened image, we can see the roads pretty clearly. And when I'm going to just toggle it on and off. So this is all from the same data, overlapping a pan-sharpening with OrbView, high spatial resolution black and white image. You can see a crispness that comes with the Brovie transformation. And in purple, we can see built-up areas and roads. And our red areas here, or higher red area values, are kind of our vegetation, healthy vegetation areas. So just messing around with pan-sharpening capabilities, bringing in Landsat imagery, merging all the bands together using the composite functionality, composite bands functionality, principal component breakdown, and a little discussion on that, and then a quick PCA development. You're going to see a lot more of that, and I encourage you to look at that moving forward. But I just wanted to show you how inside software you can do all of this pretty quickly. As well as, I think one of the things that a lot of remote sensing classes lack is demonstrating and having you actually go to internet sites, download imagery, get the imagery set where you can use it in an image processing software platform, and do that on your own. A lot of times you're just handed the remote sensing imagery, and that's one of the reasons why I wanted to show you this. Hope you guys have a great day.